Welcome to The Explainer. Today, we're diving into something we all use every single second, but maybe don't fully understand, the internet itself. We're going to follow the path of your data, from the phone in your hand all the way under the ocean and even up into orbit.
So let's start with a simple question. You snap a picture, you hit send, and poof, it's on your friend's screen, maybe halfway across the world, in less than a second. But what actually just happened? What journey did that photo take?
Well, that whole adventure begins right where you are, in what the pros call the first and last mile. This is that initial, absolutely critical hop from your device to the bigger network.
In a flash, that photo file gets shattered into millions of ones and zeros. Good old binary code. Your phone then takes that code and encodes it onto radio waves, which it beams out to your Wi-Fi router or the nearest cell tower. And then it gets converted again, this time into tiny little pulses of laser light, ready to blast through fiber optic cables.
Yeah, it's kind of wild when you think about it, but your smartphone is basically just a super sophisticated two-way radio. It's constantly translating digital stuff into radio waves and then catching incoming radio waves and turning them back into the videos and messages you see on your screen.
Okay, so that little pulse of light has officially left your building. Where's it headed next? This is where we leave the wireless world behind and get into the actual physical nuts and bolts of the internet. And trust me, it's a lot more physical than you think.
You know, the first thing you have to get out of your head is this idea of the cloud. It's a great marketing term, but it's not some magical mist in the sky. The internet is a massive, very real piece of infrastructure. The cloud is really just someone else's computer sitting in a huge warehouse connected by very real wires. Think of it like a highway system, right? Your data starts on the local roads, the wires owned by your internet provider. Those roads all lead to a massive interchange, which we call an internet hub. A lot of these are just in regular-looking office buildings, but inside, countless networks are all meeting up to swap traffic.
And from that hub, your data merges onto the global superhighway, the internet backbone. And you know what that backbone is? For the most part, it's a web of around 400 giant undersea cables that carry a whopping 99% of all international data.
We're talking about these enormous, heavily armored cables, laid by special ships, just sitting on the ocean floor. But inside all that protection, the real magic is happening in these tiny fiberglass strands, each no thicker than a single human hair, carrying our data as pulses of light through the darkness. It's incredible.
So, we have a physical path, we have the highways, but with billions of devices all screaming for attention. How does your photo know to go to your friend in Australia and not, my laptop in New York? The answer is all about rules.
See, your photo doesn't get sent as one big file. No way. It gets chopped up into thousands of little pieces called packets. You can think of each packet like a tiny envelope. It's got a little piece of the photo inside, plus the destination address and the return address.
And this right here is the absolute genius of the internet. It's called packet switching. It's not like an old phone call where you needed one single dedicated connection. With packets, they can all take different routes to get to the same place. If one cable gets cut or a router goes down, the other packets just find another way around. It's what makes the internet so incredibly resilient.
Now, this whole chaotic dance is only possible because of protocols. And a protocol is just a fancy word for a shared set of rules. I mean, a knock-knock joke is a protocol, right? Both people know the steps. On the internet, you have protocols like TCP and IP. And they're just the rules of the road that make sure every single packet gets addressed, sent, and put back together in the right order.
So we know these undersea cables are the workhorse of today's internet. But a totally new kind of network is being built as we speak. And it's not on the ocean floor. It's in the vacuum of space.
So old-school satellite internet was always painfully slow, and that's because the satellites were way up in geostationary orbit, creating this huge delay or latency. But these new systems, like Starlink, they use thousands of tiny satellites in low Earth orbit, or LEO, just a few hundred kilometers up. This slashes that delay and makes it feel as zippy as fiber optics. But here is the absolutely mind-bending challenge. At that low altitude, these satellites are just screaming across the sky at over 27,000 kilometers per hour. They circle the entire globe every 90 minutes. So on the ground, you need these incredibly advanced antennas that can track one satellite and then in an instant switch to the next one as it pops over the horizon.
And this is where it gets really cool. The satellites don't just talk to us on the ground, they talk to each other with lasers. So if your data can't reach your ground station, it doesn't matter. It'll just hop from one satellite to the next until it can.
It's a genuine mesh network in space, using lasers to shoot data through a perfect vacuum. Okay, we've gone from the bottom of the ocean to low Earth orbit, but the last piece of this massive puzzle isn't about hardware at all. It's about the intelligence, the software that's starting to run this whole global show. For a long time, the internet's traffic rules were basically baked into the hardware of every individual router. It was kind of dumb. Software-defined networking, or SDN, completely flips that around. It uses a centralized computer, like a brain, to look at the whole network at once and intelligently directs traffic where it needs to go. It makes the entire system way more flexible and way more efficient. And what all this new, smart software leads to is something people call the flattening of the internet. In the old days, your data might have had to jump across 10 different networks to get where it was going. Now, with smarter routing and more direct connections, it might only have to cross 2. The path is getting shorter and faster.
And that kind of leaves us with this one big thought. The journey of that one photo, from image to light, across oceans, and now beamed between satellites, is really a modern miracle of engineering. And as this system keeps evolving, as it gets faster and flatter and smarter, the question of who gets to control this essential global infrastructure, well, that becomes more important than ever.